Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 5 of Unit 8 D block elements, we are going to discuss about the general properties of transition elements. One we already discussed, two we discussed, atomic and ionic radii and ionization enthalpy we have discussed. Today we are going to discuss about the magnetic property of transition elements. Okay. Now in magnetic property, you must have heard about that is two types nature or two nature we see, paramagnetic and diamagnetic, if you heard about. Okay, so paramagnetic and diamagnetic, I gave you one simple, what we call it as a trick, P D P U. Clear? Means these are electrons. If paired electrons are there, the magnetic property, which property? Magnetic property. D means what? Dimagnetic. And if unpaired electrons are there, in the d orbitals, unpaired electrons are there, the magnetic property we call it as what? Paramagnetic. Understood? So here we can write for this into point form, what we say, that is majority of the substance shows magnetic nature. Majority of the substance show magnetic nature. Shows magnetic nature, and there are, after magnetic nature, full stop, there are what we call it as either paramagnetic or diamagnetic. They are either paramagnetic or diamagnetic. Sorry, there this we will write. So no need to write anything. These are paramagnetic or diamagnetic. Okay. Now, what about paramagnetic? What I said. If paired electrons are there, it is dimagnetic, and unpaired electrons are there, it is paramagnetic. You can remember like this, like this. Diagonal P must come. Okay, so it will be easier for you to remember. Okay, now the next one, when we say here, the point number 2, that is you must have studied in Unit 1. That is solid state, what you have studied. That is a paramagnetic substance is one which is weakly attracted. Magnetic substances are the one which is weakly attracted, towards magnet or into magnetic field. Clear? Understood? This I think you must be knowing. And a diamagnetic substance are the one which are strongly attracted into magnetic field. Clear? Now this you have already studied, but this is the concept which you must know what we say. Understood? Well, now the paramagnetic behavior arises due to presence of, look here, paramagnetic behavior is due to, now what we say now, paramagnetic, when we say paramagnetic means unpaired electron. Okay, so the paramagnetic behavior arises due to the presence of one or more what we call it as behavior due to presence of one or more singly occupied, what we call it as occupied atomic orbital. Understood? Now singly occupied atomic orbital, if I talk about d, like this, due to this spin, opposite parallel spin. What singly occupied means like this. This is the reason why paramagnetic behavior is observed, what we say. And diamagnetic behavior is due to, now this is singly occupied, and that what we can call it as paired electrons in the atomic orbital. Paired electrons in the atomic orbitals. Understood? Paired electrons means what? Like this, what we say, now all are completely paired, what we call, like this. Understood? This way you can remember. So paired electron, the word is what? Paired electron. This is the word what I am talking about. Okay. Well, in this case, singly occupied means what? What is the meaning of the word singly occupied? Means like this. Okay. So this is the word. So this paramagnetic property is due to this, and diamagnetic is due to what we say now. Now what we say in most of the compound, when we say I'll just do it like this, you can see. Most, what we say, of the compounds of transition elements are they are mostly unpaired. Then only it is called transition element. D orbitals, what we say. What we call the most of the are paramagnetic. The reason is unpaired electrons. Paramagnetic in nature. Understood? So that's why they shows which property? Paramagnetic properties. Understood? And we can, I'll just rub this. Okay. Now, when we say the magnetic character is expressed in term of point number 5. The magnetic property. The magnetic, what we call it is moment. Okay, we can do the magnetic character or property. Character is expressed in I think you must have studied about Bohr magnetron. The magnetic, what you call it is character is expressed in terms of magnetic, I think you can see that, no? Magnetic moment. Understood? And it is denoted by this symbol mu. Okay. And the total, what we call it as the effective total magnetic moment is given by the expression, what we call. Now in your book they have directly, textbook I think this topic is on 27, but this what I am talking about is on page number 228, what is given. Okay. Okay. Moment, and it is expressed or as, what we call it as mu, or effective magnetic total moment, what is a mu is equal to root of n into n plus 1. Okay, so where you can say mu is the magnetic moment. Okay. The unit is Bohr magnetron. N is equal to number of unpaired electrons. Okay, and Bn is Bohr magneton. Okay, now Bn, what we call it is Bohr magneton. It will be MAG, NE. Okay, so this is the unit for magnetic moment, what we say. Understood? Now, when we talk about this magnetic moment, you can see the magnetic moment increases. The one note is there. The magnetic moment. Now, when we say the magnetic moment means the value of mu increases with increase in number of unpaired electrons. Which electrons? Unpaired electrons. Clear? Now, to explain this, we can take one example. What we say, suppose Ti, titanium is Ti3 plus, it is 3D1. Okay, 3D1 means what we say, how many unpaired electrons? Only one unpaired electron. Means what? N is equal to 1. So if I substitute that value in this N, instead of N is equal to 1, 1 into 1 plus 1, what we say? Sorry, here formula it will be 2. 1 into 1 plus 2, so which is equal to root of 1 into 3, that is equal to root 3, so which is equal to 1.73 Bn magnetron. Understood? So now suppose if n is equal to 2, what we say? Another example, if you take of n is equal to 2, or if you take TL. One another example we will take here. I will write here TL plus 3, in which TL plus 3 will be 3D2. Understood? Configuration, what we say? 3D2 will be. This is the configuration 3D. Another what I am not writing. So here, therefore, what we can say, n is equal to 2. Okay. So if I substitute in mu is equal to root of n into n plus 2. So which is equal to what? 2 into 2 plus 2, so which is equal to root of 2 into 4, what we say. Understood? So root 8, or otherwise 2 into 4 only will keep. So root 2 into root 4, so which is equal to this is 2, and 2 into 1 point, what we call it as root 2 is 1.31 something, what we say. Okay, so if you count, it will be 2.84, what we call. Understood? It will be 2.84. Is it clear? So if you see, if the number of n is equal to 1, it is 1.73. If n is equal to 2, it is what? 2.84. Means if the magnetic moment is increases with increasing number of unpaired electron, means if the unpaired electron increases, the value of mu magnetic moment will also increase. That is what is given in your textbook, what is given. Okay, you can go through it, and certain what we call it as magnetic moments are given in your book, values. That is the table what you can see here. This is table on 2. These are the tables given. If you can see here, 0 unpaired electron, it is 0 here. 1, 1.2, 2.3, 3.4, 4 point, like this you can remember. Means from the value of the magnetic moment, this is calculated and this is observed. So from the value of the magnetic moment, you can easily say number of electrons. See, if the magnetic moment is what you call 4.90, we can say there are 4 unpaired electrons. Okay, so this is the easiest technique to go through the magnetic moment. Understood? Okay, so this was all about magnetic moment, what we have seen here. And the magnetic moment, one nice topic is there which I didn't explain. It is for you. You can write down here, that is the magnetic moment is due to. This is as a note, you can write it down and keep. So how does this is formed? The magnetic moment arises only from, you can see. Okay, the magnetic moment arises only from the spin of electron. Clear? The spin of electron. Understood this part? So don't forget this. Now spin of electron means what we say. When we write like this, now this is plus half spin. When we write like this, is minus half spin. Now we know that electron can spin on its axis either right side or left side, clockwise or anti-clockwise. Okay, clockwise it is plus half and anti-clockwise minus half on its axis. Okay, and due to this the magnetic moment is generated, what is being explained. Okay, so this was all about magnetic moment, what is given. There is an example 8.8 in your textbook that you can do it by yourself. Okay, so certain things what we have derived here you can see. Okay, so this was all about what we call it as the magnetic properties, what we say, of transition elements. In that we have discussed many things. Something you must have recalled, something you must come to know new today. That is, magnetic moment is due to the spin of the electron and all. Magnetic moment increases with increase in number of unpaired electrons. That tabular form you can see, table what we say. Okay, so from that you can make up. So this was all about magnetic property of transition elements. Next time we will continue with the another properties. Okay, general properties. Thank you.